I don't know.
These are actually identities that we already kind of know. You just don't know it yet. So let's start off with a couple of these. The cosecant of theta equals r over y, and we know that the sine of theta is equal to y over r. Shh. So what I want to do is I want to take this cosecant and I want to solve for y. So I'm going to multiply both sides by y here, and then I'm going to divide both sides by cosecant. All right? So that would give me y equals r over cosecant of theta. So far, so good? So what I'm going to do from here is I'm going to say that r over cosecant is equal to y, so I'm going to make that substitution into that spot there. Which means that we can say that the sine of theta is equal to r divided by cosecant divided by r. Well, if we were to invert and multiply, we would end up with r over cosecant times 1 over r, and these two r's would actually cross off, and we'd be left with 1 over cosecant. So what we've done is we've used two existing identities that we already know to come up with the brand new identity. We good there? Okay. Let me show you another way of thinking about this one. So you could actually you could say, all right, well, we were just told here that the sine of theta, we just wrote down sine of theta is a reciprocal for cosecant, so that's 1 over cosecant. And we could make a substitution in there. We could say that cosecant, we know the definition of cosecant is 1 over cosecant is equal to r over y, right? R over y. And if we were to invert and multiply 1 divided by r over y, that would give us y over r. Okay, so that's another way of thinking about it. Are we good so far? Yeah? So we're going to start off with tangent of theta is equal to y over x. And we're going to come up with the quotient identity that corresponds to tangent. We know that the sine of theta, that's an ugly s, huh? Sine of theta is equal to y over r, right? So if I were to multiply both sides, we would end up with r times the sine of theta is equal to y. Come on now, there we go. And cosine of theta, that's equal to x over r. And so if I multiply both sides by r, I'd end up with r times the cosine of theta is equal to x. So I'm going to make a couple substitutions in here. I'm going to substitute y, which is r times sine theta, and x, which is r times cosine theta. And the r's cross off, and we're left with tangent is equal to sine over cosine. All right? So far, so good? Yeah. You could actually also work backwards. You could say we have our quotient identity is tangent of theta is equal to sine of theta over cosine of theta. And we could say, oh, well, we know that sine is equal to y over r, and cosine is x over r. And if we invert and multiply, we're going to come up with the same old identity that we know for tangent, right? It's y over x. Okay. Are we good on those? Do you guys understand what I meant by you already know them kind of already? Okay. So let's move. We're going to look at the Pythagorean identities now. So we're going to start off with a right triangle in the xy system. And we have theta here. X is along the horizontal, y along the vertical, and we have our r along the hypotenuse there. Pythagorean theorem says that x squared plus y squared is equal to r squared. So let's go ahead and use this triangle to define cosine and sine. Cosine is adjacent over hypotenuse, or x over r here, right? And sine is equal to y over r. And if I were to multiply both sides by r for both of these, I would end up with r times cosine is equal to x and r times sine is equal to y. So I'm going to make those substitutions into the Pythagorean identity here. Okay, so we have r times cosine squared plus r times sine squared is equal to r squared. From here, whenever you have a trig identity to the to an exponent, you put the exponent in between the word and the angle. Okay, so that says cosine squared. And then we have r times r, and we have sine times sine. Oop. So I put the 2 in between the sine and the theta. So what happens from here is if I divide each term by r squared, I'll end up with cosine squared plus sine squared is equal to 1. So far so good? What did sine squared say to cosine squared?
What?
Hey, let's get together and become one.
No.
She actually made them.
Okay. So there's two other Pythagorean identities. And you can find those two other Pythagorean identities just by taking this Pythagorean identity and dividing by cosine squared, and then the other time you'll divide by sine squared. I'm going to show you both of them. So one of them we could divide by cosine squared. We can divide each term by cosine squared. And here we have cosine over cosine, which turns to a 1. And then here we have a sine over cosine. Sine over cosine, that's a tangent. Because we have squared, we have tangent squared. And then we have 1 over cosine squared. That's going to give us secant squared. So that's one way to come up with the other identity. Just divide by cosine, and then you come up with your other identity. And then the other one, if you divide by sine, sine squared, you'll come up with the other identity. We have cosine over sine, which is cotangent. We have cotangent squared because of the squares here and here. And we have a sine squared over sine squared, which is 1. And then we have 1 over sine squared, which is equal to cosecant squared. So if you ever forget your identities, your Pythagorean identities, you can always come up with them, hopefully. Any questions so far? So we have some cofunction identities. This one here says the sine of pi over 2 minus theta is equal to the cosine of theta. And I'm gonna show you why this one works just by plugging in an angle value. Okay, so I'm gonna plug in 0. And so if we plug in 0, we have the sine of pi over 2 is equal to the cosine of 0. We're a distance of pi over 2 away, right? The difference is pi over 2. And the sine of pi over 2 is, at this point here, we have our y over r, which is going to just give us a 1 there, right? And then the cosine of 0, we have our x over r, which is a 1 over a 1, which gives us a 1. So we have equal, okay? So with any of these cofunction identities, if you plug in a single angle value, you're going to come up with the same exact value on both sides of the equation. Now, another way of thinking about cofunction could be like horizontal shifting, right? Like one of the extra credit problems we had on one of the quizzes was how do you write sine into how do you transform cosine into sine, right? So we could take the cosine graph and horizontally shift it to the right and come up with the sine graph. So that's another way of thinking about these cofunction identities, is that they're just horizontal shifts with the graphs, okay? So these last one, these odd-even identities, we're going to focus just on the first one, where we have the sine of negative theta is equal to negative times the sine of theta. And so what I've done here is I've decided to just plug in theta equals 45. And so if I plug in 45 here, I have the sine of negative 45 is equal to negative times the sine of 45. So let's think about the sine of negative 45. Negative 45 brings us clockwise down here. And I make a 45, 45, 90 triangle. And this is hypotenuse of 2. If that's 2, then both sides are root 2. But this one here is negative root 2. And sine's definition is y over r. So we have a negative root 2 over 2. So let's think about the sine of 45 over here. Sine of 45 takes us counterclockwise. So I make a 45, 45, 90 triangle here. And we have a 2 and a root 2 and a root 2. And our definition for sine is y over r. So we say root 2 over 2, which gives us a sine of 45 is root 2 over 2. But there's a negative in front. And we say, yeah, that both sides are equal to each other. Okay? So the definitions you guys will be using mostly are the basic trig identities, consisting of the reciprocal and quotient identities, and the Pythagorean identities. Those ones you're going to want to absolutely have memorized, okay? You won't really be able to get through these sections unless you have those memorized. So it's uber important to memorize those identities, okay? Can I press stop now? You guys know I was recording that?